That is your unit 2. First topic is red black tree. Okay. Am I audible, class?
Yes,
Yes,
sir.
sir.
Okay. So this screen is visible, I hope. Is it visible?
Yes, sir.
Okay. So see, as I have already told you, a red black tree is a binary search tree. So whenever we will insert any node, first we will insert a node as we do in binary search tree. Like we'll compare the node with the parent. If it is less, it will go to left. Later it will go to right, and we keep on comparing till we get the correct position there. Okay. But apart from, it's binary search tree also, and it is balanced also. But it differs from real tree in a way that every node has a particular color. So color of a node can be either red or it can be either black. And every node contains following information: color, key, left, right, and parent. And parent. So these informations are contained in every. And these are the properties. So first thing is that every node is either red or black. The root node is always black. Remember, the root node is always black. Every leaf is black. If a node is red, then I've already told you yesterday, it's both children are black. So a red node cannot have a red child. And for every node, the back height of the tree will be same. So for each node, all simple path from the node to leaf contain same number of black nodes. So we'll discuss this with the help of an example, what exactly it is trying to say. So I will quickly show you an example. So now I hope it is visible.
Yes, sir.
Okay. So see, first property that it is a binary search tree. So if you can see in this particular figure, this 26 is the root. So all elements which are at left of the root are less than 26. So 17 is less than 26, then 41 is greater than 26. So greater element is at right. Similarly for 17, the smaller elements on the left and greater elements on the right. So it is a binary search tree, completely binary search tree. First thing. Second property source says that every node has a color. So 26 is black, 17 is red, 14 is black, 16 is black, 12 is black, 7 is black. So every node has a color. This 15 is red, 20 is red. Okay. Third property says that a red node cannot have a red child. So if you see here, 26 is black, it is having a red child, it's okay. But 17 is red, so it both child are black. There is no red node here with red. There is no node here with a red child. Next property was that number of black node on any path from any node must be same. So if you calculate from 26, so one black, two black, three black, this path. One black, two black, three black, this path. One black, two black, three black again. Then one black, two black, three black. Then one black, two black, three black. So on all the paths, see, on all the paths, what we are having equal number of black nodes for every node. So we'll check this once more. Just wait. So taking node 26. So let's count. So this path we are having one black, two black, and three black. On this path we have three black nodes. Okay. Same path again 1, 2, and 3 black node. Third path again 1, 2, and 3 black node. Fourth path again 1, 2, and 3 black node. Fifth path again black 1, 2, and 3 black node. Similarly, if you check for 41, on this path 1 and 2 black node. On this path 1 and 2 black node. On this path 1 and 2 black node. So for every for every node, it will be true. For any node on any path, number of black node will be same. For any node on any path, number of black node will be same. Remember this thing. So here on this path we have two black node. Here on this path we are having two black node. Here on this path we are having one black node. Here on this path we are having one black. So this is a very important property. So what are the properties? First property is that it is a binary search tree. Second probability is that it is balanced in terms of black height of the tree. And what is the black height of the tree? Black height of the tree is the number of black nodes from root to the, this is the black height of the tree. Third, every node will be colored either red or black. Fourth, a red node cannot have a black child. And fifth, for every node, the black height of the node will be same. It means from every node, number of black node on any path from that node to leaf will be same. I hope it is clear. What is a red black tree?
Yes, sir.
Yes, sir.
Now here are special nodes which are marked nil. If you see this, what are these actually? So I will explain you what are these. Suppose there is a tree. This is black. Suppose this is red. Suppose this is also black with 21, black 29. Okay. One zero. This is also black. Okay. This is suppose red. And here we have nine, which is black. And here we have 22, which is black. So this is a red black tree because if you count for every node, number of black node on any path are same. So this is a leaf node. 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 So for every node, we assume that they are having black childs with value. For every leaf node, we assume that they are having black child with value nil. Okay. Suppose there is one more node here, 2. So not for every leaf, basically for every empty child, we assume that there is a nil and color of nil is black. Okay. For every empty child, we assume that there is a nil and color of nil is black. So here empty child nil, empty child nil, empty child nil, empty child nil. So for every empty child, what we assume, we have a black node. We have black node with value nil. Is this clear?
Yes, sir.
So this is basically arbitrary, standard red black tree. Okay. So now again, since it is a data structure, so we have basic operations like, insert, delete, search, and traverse. So we'll study one by one all the operations, starting from insert. So insertion in red black tree, calls for several rotations. So there are 3 cases basically, where case 1 is separate and case 2 and 3 are combined. So I will tell you how to insert. So this is the algorithm. Okay, so algorithm will study after we have done a numerical, then we'll study. So let me show you how to insert. First rule is every new node represented by small z is inserted as a red node. Okay. So every new node which is represented as small z is inserted as a red node. And what we have to do after insertion, check that no parent red and child red.
Sorry, screen is not visual.
Scale is not visible. Okay, wait. Now it is visible.
Yes, sir.
Okay, so every new node represented by small z is inserted as a red node. And after inserted, first thing what we have to do, we have to check that no parent is red and its child is red. First thing. And if this second condition exists, then so if 2 is true, apply a fix up. So we have to fix this up because no parent and child can be red. So these are three things that we have to do while inserting a node in a red black tree. So every new node will be inserted as red node. We'll represent that node as Z. After insertion, we'll check that there is no case where parent and child both are red. And if this condition is true, then we have to apply several fix ups. Okay. So let's see an example. So suppose this is a red black tree. Okay. Now suppose, for example, I have to insert value 309. Okay. So since it is a binary search tree, so I will insert 309 here as a red node. So here we have a red relationship. So we have to apply fix up. So for applying fix up, what we do, we check the, color of sibling of parent of Z, which we represent with Y. Always remember, sibling of parent of Z is Y, or we can say Z uncle is Y. So this is parent, it is the sibling, so it is. So you have to check what is the color of Y. For every inserted node, what we'll do, we'll check the sibling of parent of Z. Or in short, we'll say the color of Z's uncle. We'll check. Okay. So color of Z's uncle here is red. This is one case. Second case is that color of Z uncle can be black. There are two cases. For a newly inserted node, sibling of parent of Z can be black or sibling of parent of Z can be red. And based on these two conditions, there are three cases. Case 1, case 2, and case 3. So we'll discuss all these three cases. I hope this is clear, class.
Yes, sir.
So for every inserted node, what you have to check? You have to check the color of uncle of Z, that is sibling of parent of Z. So if it is red, we'll apply some other case. If it is black, we are going to apply some other case. In this way, there are total three cases. So I will explain you one by one each case. So case 1, just wait. So first is that insert node as we do in binary search tree. Color of node is red. Okay. So now case 1. So we know that new node we are implementing by Z. To case 1 says that Z's uncle Y is red. Okay. So we represent case 1 like this. Okay. Okay. So this is a red black tree. So this alpha, beta, gamma, delta represent the subtrees which are already balanced. Okay. This is a red black tree. What we'll do here, we'll insert element B. So this is black color, this is red color, this is red color. Now we are going to insert B. So B is less than D, so it will go to A, and it is greater than A, so it will go to the right side. So after inserting B, what will happen? So this is the newly inserted node. Its color is red. Here it is red. Here color is black. So here we have a red and red relationship between parent and child. So this is not acceptable. What we'll do, we'll find Y. So this is Y node. And what is color of Y? Red. What is color of Y? Red. So since color of Y is red, we'll apply case 1. So what case 1 says that? This is D. Every time I'm writing these now. Now understand it carefully. This was the initial case. Now this line which is attached from D says that this whole structure is a part of a tree. It is a subtree. So D is not a root. Always remember this. D is not a root. It is part of a tree. Okay. Now, in this part of a tree, I have to insert B. So B proper place is this. So in place of beta, now B came. And this is the new inserted node Z and color is red. So after inserting, we got a red relationship. So we have to fix up. So we'll go to case 1 because Z uncle Y is red. So color of Y is red. So we are applying case 1. Case 1 says that, that parent and uncle of Z will become black. So A became black, C became black. And parent and parent of Z will become red. So it became red. Got it? Class. So if we take an example, like for example, so this is 26, this is suppose 17, this is 41, this is black, this is red, and we insert, for example, 38, not 38, sorry, we insert 22. So after insertion, what will happen? 26, it is black, 17 is red, here 41 is red, 22 is red. So this is Z. So again, we have a red relationship. So we'll see for Y. Y color is red. So we'll apply case 1. So after applying case 1, what will happen? This will become black. This is red. This will become black. But now since 26 is root, so it cannot be red. So forcefully, if our root is red, we'll forcefully convert into black. So finally, what we'll get? Is this clear, class?
Yes, sir.
So you have to do nothing in case A1, case 1. In case 1, you just have to change the colors. So color of the parent of newly inserted node, color of its uncle will become black, and color of parent will become red. And if parent of parent is a root, you will again turn it black. Otherwise, you will leave it like that. And the most important thing is that here again we are pointing D as Z. So why we are pointing this? Because suppose after insertion, we again have a red relationship. We again have a red relationship. So I will show you one more example. Why we have pointed it at Z. Just wait. Suppose we have a tree like this. Hmm. So this tree is perfectly balanced. If we check any path, like suppose from 26, if we are checking on this path, we have two black nodes. On this path, again we have two black nodes. On this path also we have two black nodes. On this path also we have two black nodes. Similarly, from 17, from 9, from every node, if you check, we have two black nodes. Fine. So this tree is perfectly balanced. Now suppose I'm removing this part thing. This we have already discussed. Okay. Now suppose what I want to do, I want to insert 0. So basically see 0 will be inserted here at the left of 1. Okay. So after insertion, what will happen? This is the newly inserted node. Okay. So what we'll do, we'll check for y. Y is the uncle of 0. It means parent of sibling of parents. So y, its color is red. So what we'll do, the color of parent and the color of uncle will become black and parent of will become red. So after inserting 0, we are getting 26, 17, 9, 1, 0,
पापा
11.
मोबाइल में चालू हो गया
Mute your systems, otherwise I will throw you out of the class. So if you remember case A says that if we have something like this, D, A, B, so this is black, this is red, this is newly inserted node red, this is Y which is red. So after inserting D, what happens? D become red and it is now marked as new Z. A becomes black, C becomes black, and D remains red. So this is D basically. This is what? This is D, D node. So if you see here, what happens? Parent and sibling of parent become black. So parent and sibling of parent, it became black. And parent of parent become red. So parent of parent, this became red. So after becoming red, again we have a red relationship. Is it visible here, class?
Yes, sir.
Is this thing clear? So
Yes,
even
sir.
after applying case A, again we are having red relationship. So we have to resolve this. And for resolving this, we again see the color of sibling of parent of 9. So color of sibling of parent of 9 is black. So this will cover in case 2 and case 3. So now this is Y. Since this is Z now, so this will be Y. So Y color is black. So we have to study case 2 and case 3. So I hope case 1 is clear to all.
Yes, sir.
Yes,
Any
sir.
confusion to anyone in case 1? If there is any confusion, let me know. I will repeat it right now. Is it clear?
Yes, sir.
Okay. So now we'll see case 2. Okay, so we have to, look into these two cases together because they are, when we'll apply case 2, then we'll get into case 3. So case 2 basically results in case 3. So case 2 says that Z's uncle Y is black and Z is the right child, and case 3 says that Z's uncle Y is black and Z is the left child. Okay, so let's see. We have to change some figure. This figure will not work. Just wait. So this is the case. Okay. So this subtree is perfectly balanced. These two subtrees are perfectly balanced. Now what do I want? I want to insert B here. Okay. Okay. And this is the case. So this is Y. So when nothing is given, we assume it is black. So this is Y, which is black. So red relationship is there. This is the Z node and uncle of Z, Y is black. And Z is the right child. So what we'll do, we'll apply case 2. In case 2, what happens? B will push A to the left. So what we'll get? Okay. But this will be become new Z. Red, red, black. Okay. Like this. Now what happened? Since now this is Z, we'll check its uncle. So parent sibling of parent is Y. Again, we assume it is black. It is black. So and Z is now left child. So now we'll apply case 3 here. So after applying case 3, this will get. And this will be still Z. Okay, now see it once more. So sibling of the parent must be black and Z is the right child. So this was the tree. We inserted B here. It became Z with a color red and its sibling uncle Y is black. So since it is a right child, we applied case 2. What case 2 will do? Case 2 will push B here and A to the down. A will become Z. So now A became Z, no change in color. So as soon as you will apply case 2, you will get into case 3. What case 3 will do? Case 3 will take B as parent and change this color to black. So B is a parent, now color is black, A and C, and A is still the new Z. I hope this is clear, class.
Yes, sir.
Okay. So now I will take an example which covers all the 3 cases. Okay, that will be more clear to you. Okay, this is a red black too. So first what we'll do, we'll insert a node here. Insert 4. So obviously 4 will go to the left of 5. So after insertion, what we'll get? Okay. So since we are getting red relationship, this is the new node. We'll check its uncle Y. It is red. We'll apply case 1. So apply case 1, 5 and 8 will become black, 7 will become red. So after applying case 1, and this is new Z. So again we have a red relationship. So this is Z. So now again we'll check its sibling. So Y color is black. So Z's uncle Y is black and Z is the right child. Z is the right child. So now what we'll do, we'll push Z here and 2 and 1 will be shifted down. So case 2. When we'll push it, it will become like 5, 4, 8, 14, 15. And no change in colors. Now it became Z. So now this is Z. So we'll again check its uncle. So this is parent, this is sibling Y. Again, its color is black and Z is the left child. So we got case 3. So in case 3, this is A, this is B. So this will become parent. This will become red. Okay. So this 15 was initially red. We have nothing to do here. This was red, not black. Now see once again. So this was our tree. We inserted 4. 4 got here. Red, red. We checked the uncle of 4. Uncle of 4 was red. So we applied case 1. After applying case 1, what happened? 7 became red. These two became black. 7 became red. These two become black. And 7 become new Z as per the algo. Now again we are having a red relationship. So again we'll check uncle of 7. Uncle of 7 is black. Then check whether 7 is left child or right child. 7 is right child. So we'll apply case 2. What case 2 will do? Case 2 will shift 2 and 1 downwards without changing colors. So no color is changed. This 2 1 shifted downwards. This became right subtree of 2 as in AVL tree, and this tree we got. Now again our red relationship. Now 2 is the new Z. So again we'll check the uncle of 2. Uncle of 2 is Y. Again it is black and 2 is the left child. So again what we'll do? We'll apply case 3. Case 3 says that parent of 2 will become root. So 7 became root and color of 11 will change. So these two color got exchanged. Okay, the rest all colors are same. So this is the complete illustration of the all 3 cases. Is it clear, class? Is it clear? Yes or no? Let me tell you once again.
सर फिर रिपीट कर दीजिए.
Yeah, I am repeating. I hope this is visible.
Yes, sir.
So this 4 was inserted. Okay. So after inserting 4, we have a red relationship here. So this is red, the red, this is red. So we'll check the uncle of 4. Uncle of 4 is this one, this node Y, which is red. We have applied case 1. So after applying case 1, what will happen? 5 and 8 will become black, 7 will become red. So 5, 8 become black, 7 became red. And 7 also became new Z as per the algorithm. So again, we have a red relationship. So again, we'll check the uncle of 7. Uncle of 7 is black. This is Y. Then we'll check whether 7 is right child or left child. Is the right child. So we got into case 2. What case 2 says? Case 2 says that 2 will be pushed downward, 7 will be pushed upward. So 7 pushed upward, 2 became downward, it became Z. Left subtree of 7 become right subtree of 2. Simple. Again, we have a red relationship. Now 2 is Z. So again, we'll check the uncle of 2. Uncle of 2 is 14y, which is black. So again, we'll check whether 2 is left child or right child. So 2 is right child. So we'll do case 3. So case 3 says that parent of Z will become root. So 7 will become root and its color will be changed to black. And the previous root will change to red. Rest all colors are same. These are 3 cases. Is it clear?
Yes, sir.
Yes, sir.
Okay, so this example is given in Coreman also. I will upload the notes and recording also, so don't worry about this. Okay, so quickly we'll see a numerical where we'll create a red black tree from scratch from the first node. Okay, let's do that. Let me have a numerical from somewhere. So we have a question here. Construct a RB tree from 41, 38. Then we have 31, 12, 19. Okay. So these are the keys given and we have to construct the red black tree. So step 1. Step 1. Insert 41. So 41 will be inserted as a red node, and since it is a root, it will be forcefully converted to black node. Now second, insert 38. So 38 will go to left of 41 as a red node. Now third is insert 31. So 41 is black, 38 is red, and again 31 is red node. So here we assume that nothing is given, it is black. Here also nothing is given, it is black. So we'll check the sibling of parent of 31. This is Y, black, and 31 is the right child. See here carefully. 31 is the right child and its uncle is black. So we'll apply case 3. So after applying case 3, parent of 38 will become root. Okay. Now fourth, insert 12. So we'll insert 12 here in 38, 31 red, 12 also red, 41 also red. This is black. So again we'll check the uncle of newly inserted node, that is Y, which is red. So case 1. So what case 1 will do? 38 will become red. This will become black. This will become black. This will become red. Okay. But since it is root, so it will forcefully be black. Now we have to insert 19. Step 5. 19 we have to insert. Okay. So 38 is black, 31 is black, 41 black, 12 is red, and 19 we are inserting here. So again we have a red relationship. This is Z, so we have to see uncle of 12, uncle of 19. So uncle of 19 is nothing given here, so it means black. So Y is black.
तो कुछ कितना घूमता है उठ जा
Again we'll check whether 19 is left child or right child. So 19 is right child, so we'll apply case 2. So case 2 is applied, so 19 will go here, 12 will come down. So after applying case 2, what we'll get? 38, 31.
अगो ना मार दे
कौन है ये गधे? Those who are not muting themselves. idiots. मार देंगे पीट देंगे सब्जी में. So case 2. So why case 2? Because 19 we have inserted, we have a red relationship, and uncle of 19 is black. And since the newly inserted node is right child, we are applying case 2. So after applying case 2, what we'll get? 31. Then here we'll get 19. Then here we'll get 12. So no color is changed. This is the new Z, and 41, which is black. So now you see again we have a red relationship. So this is the newly inserted node. We'll check its uncle. So its uncle, nothing is given. So it is black and it is left child. So we'll apply case 3. So after applying case 3, what will happen? 19 will become root here. So 38. Now instead of 31, 19 became root of this subtree. 31, 12, and 41. And color will change. This will become black. This is red, red, black, and so this is the red, black tree. I hope it is clear, class.
Yes, sir.
Okay, so I'm giving you some questions. Try to solve it at home. And if there is a problem, we'll discuss it again because it is very important numerical. It's often asked in externals. So just wait, I'm giving you a question. And please mute your mics while class. Only unmute when you have to answer, when you have to ask some question. It's Komal ma'am lecture.
Yes,
sir.
sir.
Tell her that I have left 5 minutes late. So quickly write down the data. Shall I speak now?
Yes, sir.
Yes,
Write
sir.
down 2, 1, 2, 1, 4, 5, 9, 3, 6, 7. Okay, write down one more very quickly. Write down one more. Second question. 5, 16, 22, 45, 2, 10, 18, 30, 50, 12, 1. Okay, so try solving these two questions and we'll meet on Monday, hopefully. Okay,
Yes, sir.
Okay, sir. Thank you, sir.
and check your CTs. And please, 1 minute more I will take. Some of you have done so much idiotic work, like Kusad. He has uploaded one page 4 times. Pages are uploaded in landscape mode. Same thing, Mustafa, Priya, they have not done their CT on A4 size paper. Some CT files name RCA 303 or something. While I have strictly told you to write roll number underscore name. So this time I have checked all the copies, but then next any exam, whether it is assignment or CT, if you are not following guidelines in any subject, you will be marked as absent. Okay?
Yes, sir.